Hello everyone. Today I am here to talk to you about the importance of digitally connecting 3D measurement data to your engineering and manufacturing processes. But first, let me share awesome news with you. The digital transformation of 3D measurement processes is now a reality. You can engage in your transformation without fear. And the benefits of transforming your 3D measurement processes are huge. The Innovametric Group, to which I belong, is recognized as a visionary leader in 3D metrology since its inception 30 years ago. We pioneered point cloud-based dimensional inspection as early as in 2000. In 2006, we had the vision of a universal 3D metrology software platform and worked tirelessly for 10 years to deliver it to our clients. Throughout our history, we made it our specialty to anticipate major market trends. In 2011, we created a complete specification describing how we could manage and share 3D measurement data digitally within manufacturing organizations. This led us to invest over $30 million to develop our software solutions for next-generation digital 3D measurement processes. This incredible journey was made possible by the participation of early adopters. These users of our 3D measurement solutions provided their requirements and precious feedback to help us prioritize our development projects, as well as improve and optimize our digital toolbox. Here, I would like to highlight a client who offered an exceptional level of collaboration and allowed us to accelerate the development of our digital solutions by sharing detailed requirements and diligently testing our new functionalities for 4 years. That company is GE Appliances. Let's hear them explain in their own words how digitally connected 3D measurement data help them make better data-driven decisions.
Many companies talk about a digital transformation, and at GEA, that digital transformation is really what's driving us forward as a company. It's allowing us to grow, it's allowing us to outperform.
If you incorporate these tools into your design process up front, you're able to do assessments, you're able to do simulations, you're able to do analysis digitally before you ever spend a dollar on doing prototypes or building up things.
We quickly realized that all the 3D data in the world is not that valuable if engineers can't get their hands on it. So it's really important that they have ease of access so they can make decisions fast. So the leadership team was all in from the beginning and really pushed that entrepreneurial spirit to really think big and dream big. Our relationship with Innovametric is very special to us, and it's one that's helped us innovate together. Innovametric has helped push us in our processes forward, and we've helped push the development of the software with them forward.
We have 20,000 customers worldwide and work with 98 of the world's 100 largest manufacturing organizations. We can count on one hand the companies that have achieved what GE Appliances has achieved in terms of digital processes.
You think about where we were 5 years ago versus today, it's absolutely incredible.
At GE Appliances, access to 3D measurement data via a web interface was the key element in their transformation. But what about the improvements to the 3D measurement team performance? Our Japanese customer, Futaba, a global automotive stamp parts manufacturer with over 10,000 employees, provides the answer. After implementing our data management solution to manage and share all their 3D inspection projects digitally, they reported a whopping 45% reduction in the time needed to do their 3D measurement work. In other words, 45% of the time of their 3D measurement team could be redirected to other tasks. Or the company could do twice as much 3D measurement work without hiring more people. With the aging of the workforce and difficulties in attracting and retaining quality workers, who can afford not to recover 45% of their 3D measurement time? If we are here today to talk about the importance of digital processes for 3D measurement, it is because there has been a major increase in the use of 3D measurement in the manufacturing industry over the past 25 years due to the dazzling evolution of point cloud measurement technologies. Let me mention two examples. Portable and easy-to-use laser scanning systems provide the ability to quickly take 3D measurements from any individual piece or assembly anywhere on the shop floor without any surface preparation. And off-the-shelf, robot-based 3D measurement stations can be deployed to implement automated 3D measurement processes. While point cloud measurement solutions were rapidly evolving, the performance of computers was also improving exponentially. 50 times increase in the amount of available memory, 8 times increase in the number of CPUs, and 30 times increase in terms of 3D display speed. For software developers like us, it was a feast. We made good use of these improved hardware technologies to successfully expand the use of 3D measurement technologies throughout our customers' dimensional management process. Today, 3D measurement technologies are used to reduce the number of prototypes and iterations needed to deliver functional manufacturing tools, fine-tune the product and accelerate the assembly process, and detect, analyze, and fix manufacturing issues that occur during production. As customers had more and more success deploying 3D measurement technologies throughout their dimensional management process, the amount of 3D measurement data generated literally exploded, growing exponentially. This large amount of data, combined with the increasing number of people and departments that wanted to consume it, has resulted in major process complexities that have greatly increased the cost of measuring in 3D. Our own survey concluded that 3D measurement specialists spent more than 3 hours every week finding, filing, and sharing inspection project files with colleagues. Multiply these hours by the number of employees involved, their salaries, and the number of weeks in a year, and you'll see how expensive it is not to be digital. Where do we go from here? How can we keep reaping the benefits of 3D measurement technologies while controlling the cost of 3D measurement? To find out, we first need to make an assessment of our customers' current 3D measurement processes. For several manufacturing organizations, process complexity starts right in their 3D measurement labs, where they sometimes use more than 5 different software to measure in 3D and analyze the information obtained. 1 or 2 software on their CMMs, 2 or 3 for portable metrology systems, and 1 or 2 for their digital gauges. Using such a large number of software hinders the performance of 3D measurement teams. It creates team silos that restrict mobility, limit teamwork efficiency, and encourage operators to build superficial knowledge of each software. The risk of errors is higher as measurement projects must be duplicated and adapted for each software solution. And data management increases in complexity as each software has its own proprietary format, requiring added processing to aggregate the data into formats that engineering and manufacturing teams can digest. In addition, 3D measurement teams are too often gatekeepers that prevent engineering and manufacturing teams from directly accessing 3D measurement information. Measurement files are often hidden on local hard drives, and there is no search engine to facilitate finding the data, which leads to manually sharing 3D measurement data with colleagues who need this information to do their work. Finally, 3D measurement processes are typically isolated and not well integrated within the organization's core digital processes. I have 3 examples to share here. The first example is 3D measurement planning. The 3D measurement plan is an important communication tool that conveys a part's 3D dimensional requirements as defined by the design and manufacturing teams. Look at existing processes of defining and sharing 3D measurement plans, however, and you'll find out that they are time-consuming and error-prone. With 2D drawings, the 3D measurement specialists must interpret the information and manually create all the 3D objects and dimensional controls that will be measured. An alternative solution to 2D drawings is to use the CAD software's PMI technology that automates the import of design requirements within 3D measurement software. However, PMI is incomplete, as many types of dimensional requirements that are routinely needed for manufacturing or analysis purposes still need to be defined interactively within 3D measurement software. As a second example, repeatability and gauge R&R studies. These studies are important to guarantee the reliability of your 3D measurement processes prior to certifying production tools. Today, they generally involve the use of 3 or more different software, such as 3D measurement, spreadsheet, and statistical software. These studies also require numerous software manipulations, manual file exchanges, and statistical expertise. As a third example, preparing and sharing inspection reports. Most companies still rely on 2D PDF files to share 3D measurement results. But how can product engineering and manufacturing teams understand and solve complex 3D-dimensional manufacturing issues solely by reviewing 2D reports? Not easily, that's for sure. In the extended version of the video testimonial presented earlier, Kevin Nolan, the CEO of GE Appliances, tells us that 3D metrology was at the base of his company's digital transformation. And without a proper digital infrastructure in place, companies will keep experiencing the challenges I've just presented when using 3D measurement technologies at scale. To expand your 3D measurement capabilities and maximize the value of 3D measurement data while controlling your costs, there are 3 key digital transformation steps: the standardization of 3D measurement workflows, data management on a central server, and the digital interconnection of 3D measurement to other digital enterprise solutions. The secret to a successful digital transformation is planning a gradual implementation that ensures buy-in from all stakeholders and minimizes business disruptions. Moreover, after each step, there should be a significant return on investment. The transformation of 3D measurement processes starts in the 3D measurement labs. We have already explained how using multiple software hinders the performance of 3D measurement teams. But did you realize that it is not only the 3D measurement teams that are suffering from the use of multiple 3D measurement software, but also the engineering and manufacturing teams that consume 3D measurement data? If multiple software applications are used, the 3D measurement results are stored in multiple files in different proprietary formats. So, the only way for other teams to aggregate this information is to export all the data externally in a neutral format and re-import the data within another software, for example, Excel. In addition, if you are using multiple 3D measurement software, your engineering and manufacturing teams might also need to use multiple 3D reviewing software. So the use of multiple 3D measurement software has a global impact on your organization. The solution to reducing the number of software is a universal 3D metrology platform. It provides a universal 3D digitizing hub. This is the capability of handling all types of 3D measurement devices within a single software. This includes portable metrology systems, CMMs, digital gauges, and even visual checks. As a universal data hub, a universal platform also has the capability of importing data from other software when a direct connection to a 3D measurement device is not possible. In automated systems, for example, there is a very tight integration between the robot, the 3D measurement device, and the software. In this case, the only way to import 3D measurement data could be through a file import. While obtaining data from any 3D measurement device is clearly necessary, it is not enough to be considered as universal. A key characteristic of a universal platform is that it provides 3D measurement specialists with a universal metrology workflow that allows them to perform all the planning, execution, and analysis tasks of a 3D measurement activity using the same tools and interfaces, regardless of the type of 3D measurement technology involved. Finally, a universal platform needs universal inspection projects so that all 3D measurement templates and measurement results for a specific part can be stored within a single project, regardless of the technology used for measurement. Universal projects make analysis and reporting easier for all the consumers of 3D measurement data enterprise-wide. So, the universal platform simplifies the life of engineering and manufacturing teams, since they can consume all their company's 3D measurement data from a single source. Interestingly enough, a universal platform also delivers individual benefits that boost the performance of 3D measurement team members. Portable metrology operators are learning to use CMMs, and CMM operators can master portable metrology. Teams become more versatile, making it easier to continue with the work despite the absence of a colleague or the unavailability of a device. Operator skills are also enhanced through deeper dimensional inspection knowledge, thanks to one software that they can apply for all their tasks. Once the workflows of the 3D measurement teams are standardized through a universal platform, what comes next? As Dave Leone, Senior Director at GE Appliances, says, all the 3D data in the world is not that valuable if engineers can't get their hands on it. That's why it's vital to have a robust and efficient system for delivering the valuable data produced by the 3D measurement teams to the engineering and manufacturing teams. This is achieved by managing 3D measurement data digitally on a central server. Storing all 3D measurement data on a central server represents a true paradigm shift, as managed data is no longer trapped on a local hard drive. The 3D measurement teams don't even need to explicitly share their data anymore. Once an inspection project is uploaded, it can be consumed immediately by anyone with the right permissions. As we have seen with our client Futaba, a data management solution significantly improves the performance of 3D measurement teams on day one. It frees them from the tedious task of managing file naming conventions or a complex structure of folders on a network drive to save their metrology projects. They just upload the projects on the server. All files and folders are managed automatically. They also no longer need to manually browse for files. They can now search for data using keywords to find what they're looking for. Finally, a data management solution enables multiple operators to measure many pieces simultaneously and upload these measured pieces in the same inspection project at the same time. For consumers of 3D measurement data that need this information to make crucial decisions every day, a data management solution provides a modern digital infrastructure that simplifies life at work. Everyone in the organization can easily consume 3D measurement data and results through web and mobile interfaces, increasing mobility and flexibility. For example, it becomes easy to consume 3D measurement data while working from home. Even more importantly, Everyone can now share 3D measurement data with colleagues through lightweight hyperlinks, since all 3D measurement data have a unique parametric URL, the same technology used by web browsers to navigate the internet. Finally, a data management solution is a boon for IT teams. They can manage user permissions to control who has access to data and what can be done with it. Network performance is improved as only the minimum amount of information is transferred when communicating with the data management server. And the database can be backed up regularly to preserve the company's precious 3D measurement data. And that's not all. The technical foundation provided by a data management solution opens up exciting new possibilities that were unthinkable before, such as digital collaboration between colleagues located at different sites. Everyone can now seamlessly exchange and review 3D measurement information regardless of their location. In addition, the integration of suppliers to an OEM's database to access suppliers' 3D measurement data in real time means it is now possible to leverage this information to reduce time to market and improve the initial quality of a new product. A central data management system makes easy data access a reality, but one more step is required to efficiently integrate 3D measurement processes into your digital enterprise processes. Since manufacturing organizations use multiple digital solutions within their dimensional management, the efficiency of that process could be greatly enhanced by digitalizing and automating data flows through digital bridges. Let's now explore 4 examples that demonstrate the vast potential of integrating 3D measurement within a company's digital thread. The first example is 3D measurement planning. We've already presented the limitations of 2D drawings and PMI technology. To resolve these issues, we need digital bridges between CAD software and 3D measurement software. They are necessary to define all the design and manufacturing dimensional requirements within the CAD platform, while also ensuring a seamless import of the measurement plan within 3D measurement software. By tying dimensional requirements to CAD geometry within CAD software, we would ensure that all the dimensional requirements are updated when the CAD model is modified. We would also automate 3D measurement plan updates when importing a new CAD model revision within an existing inspection project. The second example is about repeatability and gauge R&R studies. In an ideal world, customers would like to use a single software to perform their repeatability or gauge R&R studies. However, it is not an easy task for software vendors like us to achieve this objective, as customers want to customize the reports for their needs, and nobody in the industry wants to code another spreadsheet software. But what if we could instead automate the transition between 3D measurement software and Excel? From a user standpoint, such a digital integration would behave as a single software solution. To achieve this objective, we would need to develop a digital bridge within Excel that would use an API from 3D measurement software to digitally link individual spreadsheet cells to 3D measurement information. It would then be possible to create Excel templates that leverage the statistical and visualization tools of Excel while allowing customers to fully customize the spreadsheet to their needs. The third example is about 3D inspection project preparation. The preparation of a CAD-based inspection project involves importing a CAD model with its embedded 3D measurement plan. Several manufacturing organizations manage their CAD data using a product lifecycle management system, also called PLM. When the 3D measurement team does not have access to their company's PLM, it can take several hours before they obtain the latest revision of a CAD model from a colleague with the right credentials. If we were to provide a digital bridge between the PLM and 3D measurement software, 3D measurement teams could search by themselves, within the PLM and get the CAD data they need in minutes. Finally, the fourth example is about dimensional management dashboards. Managers that monitor dimensional quality need dashboards to measure the performance of their production processes. Depending on the tools and processes used by the organization, these dashboards present numbers and graphs from an hour ago, a day ago, or even a week ago. With a digital bridge between Excel and the data management system, it would be possible to prepare dynamic dashboards that present quality data from a second ago. These four examples clearly show the value of bringing 3D measurement data at the heart of your enterprise's digital processes through a digital transformation. Let me now recap today's presentation. We've seen that the use of 3D measurement data has exploded in recent years, and we've exposed the inefficiencies and sources of errors of current 3D measurement processes. We've also presented a three-step digital transformation roadmap to keep expanding the use of 3D measurement while controlling 3D measurement costs. Our proposed roadmap can be summarized using only 6 words. Universal platform. Standardize the workflows of your 3D measurement teams to boost their performance. Data management. Free your 3D measurement teams from the tedious task of managing files and folders and deliver 3D measurement data in real time to all engineering and manufacturing teams through web and mobile interfaces. Digital interconnections. Digitally interconnect 3D measurement to the other digital enterprise solutions to improve efficiency and reduce the number of software used by your organization. All the digital tools, processes, and benefits we've presented today are real and provided by the PolyWorks Enterprise Solution. You are more than welcome to engage in conversation with us. We would be pleased to assist you in your digital transformation journey.